Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 8 Notes 6. We're going to be talking about areas of regular polygons. Okay, so regular polygons are polygons that have all the same sides. So if there's 5 sides, all 5 sides are the same length, and that's what makes it regular. So first thing we want to define is, and maybe just write that down, so for a regular polygon, all sides are congruent. Wow, that worked well. Okay, so let's first start by talking about an apothegm. And I'm actually think I'm going to type this because I think that'll be so much prettier. So what is an apothegm? An apothegm is a segment, that's really big, is a segment drawn perpendicular to a side of a regular polygon. A segment drawn perpendicular to the side of a polygon. So this right here, FP, is an apothegm because you notice it is perpendicular to the side of the pentagon AB. So that makes PF a apothegm. So then what is the central angle? Now we talked about central angles when we talked about circles. So it's going to be pretty similar. The vertex of the central angle is at the center of the polygon. That makes sense. That's the same as a circle, right? That's the same definition as a circle. So if we want to find the degree of the central angle, all we have to do is take 360 and divide it by n, where n is our number of sides. So we're just going to take 360 and divide it by n, where n is our number of sides. Okay? So let's go ahead and let's take a look at this a little bit. So taking a look at number 1. So square FGHJ is inscribed into a circle K. So we first want to identify the center of the square and the circle. And our center is going to be at K. And then our radius is going to extend from our center out to the outsides of the circle. So our radius could be KG or KH. Either of those are the radius. An apothegm, now remember the apothegm needs to be perpendicular to the side of the polygon. So the apothegm is going to start from K and it's going to go to L. So KL is our apothegm. Now for our central angle, remember our central angle needs to go through the center of the circle. So I see what goes through the center of the circle and the center of our square is this angle GKH, which we also could write angle H, and once these go away, oh, for Pete's sake, HKG, okay? All right, so then let's go ahead and let's take a look at the measure of our central angle. So to get the measure of our central angle, we're going to take 360 and divide it by how many sides we have, which is 1, 2, 3, 4. So we're going to take 360 and divide it by 4. So that's going to give you 90 degrees. So that's 90 degrees. Next, let's go ahead and let's take a look at number 2. So the center of our polygon is at R. The radius is going to extend from R to the outside, so R to K and R to L. So we have RK and we have RL. The apothegm is going to extend that way from the center to the side of our polygon here. So that makes RS our apothegm. Our central angle, remember, needs to go through the center of the circle. So to go through the center of the circle, it's going to be KRL. So we're going to have angle KRL or angle LRK. Either way, it doesn't matter. Now to get the measure of the central angle, we're going to take 360 and we're going to divide it by how many sides we have. Well, we have 1, 2, 3, 4, 5, 6. So we're going to take 360 and divide it by 6. And when we do that, we get 60 degrees for the measure of our central angle. So next, let's go ahead and let's take a look at number 3. Find the area of a regular hexagon with side lengths of 9.23. So the first thing I want to do is calculate out the area of just this triangle right here. So my height is 8. Well, what's my base? Oh, I see you guys, I have 5 on here. You guys have 9.23 on your sheet, so we'll use that one. So we want to find it with a side length of 9.23. Okay, so now what we're going to do to calculate the area of the triangles, we're going to do 1/2 base times height. So you can go ahead and you can multiply 1/2 times 9.23 times 8. Multiply that in your calculator and we get 36.92 centimeters squared. Now that's for the area of just that triangle. And you're probably thinking, Ms. Humbert, how on earth is that going to help me with all of them? Well, we can go ahead and we can kind of cut it like a pizza and make a bunch of different triangles. Now, all of those triangles are congruent. So we have 1, 2, 3, 4, 5, 6. We have 6 triangles of measure 36.92. So we're going to take 36.92 and we're going to multiply it by 6. And when you multiply that out, you get 21.52. And then we want to write centimeters squared because we took and we multiplied for all of the squares that we have. Okay, so what I want you guys to do before we calculate this out actually is I want to give you guys a formula. So you have some space at the bottom of the backside of your note sheet. So to find the area of a regular polygon, what you can do is you can take 1/2 the apothem times the perimeter. So this guy right here is the apothem. So to find it, you can do 1/2 the apothem times the perimeter. So that's a formula we're going to be using for these last 2 problems. So that's another way of doing it besides just using the triangle method like we used on the previous part. So let's go ahead and let's take a look at that. Okay, so we have a regular polygon. That means that each of these sides are 20. I'm getting a lot of emails today, guys. I'm sorry. So then we want to go ahead and use that formula I just gave you. So we're going to do 1/2 times the apothem. This right here is the apothem because it goes from the center and it's perpendicular to a side. So the apothem is 13.8 times the perimeter. Well, what's the perimeter? We need to do 20 plus 20 plus 20 plus 20 plus 20. So really, it's just 20 times the 5 sides, which is 100. Okay? And now all we have to do is multiply that out in our calculator. So we have 0.5 times 13.8 times 100. And when you multiply that out, you end up getting 690. And now we want to label it. Our label is meters. Since we're talking about area, we're going to square it. So we get 690 meters squared. Next, let's take a look at this one. Find the area of the regular hexagon. So, again, we know the apothem is 8 feet because it's perpendicular to the side. Likewise, each of these sides are 8 feet because it's a regular hexagon. And now we can use that formula. So we have 1/2 times the apothem, which is 8, times the perimeter, which is going to be 8 plus 8 plus 8 plus 8 plus 8 plus 8. You add all of those together and you get 48. So then in my calculator, I'm typing 1/2 times 8 times 48. And I get 192. My label is feet, and then I want to square it because I'm talking about area. So that concludes your note video today. Go ahead and show me your completed note sheet when you are done. Thanks for listening.